Okay, my friends, this is shocker du jour, and this is not going to be a good one. I was just watching all the new scientific discussion about these wildfires and the impact they're having on the earth and specifically on water. Because obviously there's a ton of water coming down everywhere, and that water is causing all kinds of trouble. Look at new discovery transforming understanding of crystals. I know what they are. Challenging conventional wisdom. Everything's challenged now because nothing they thought was right is right. It's just dogma at this point. And the same thing with space. Why? I'm sure you don't know about this. Very few people do. Planes may have to fly higher to avoid turbulence. The lowest part of Earth's atmosphere has been rising. The lowest part, like the shell around, has been rising 164 feet per decade since 1980. So the atmosphere is inflating. And now these fires, anytime you burn anything, combust anything, turn something solid into gas, you expand. All right. Well, what can make it contract? Because right now it's expanded to a point that the scrub zone out here is so intense that's why we're getting these weather patterns, these formations of tornadoes and hurricanes and monsoons and deluges of water and ice, big, huge balls of ice. I can explain all of this. Now, they want to know what the impact of, these regional impacts. Well, what I was watching was about NASA. And they're taking all of this information about around the globe and how these extreme events have damaged or interfered with local water supplies. This is not good. This is not good at all. I'm telling you this right now. You better pay attention, and they better pay attention, because I understand this, and they do not. I'm just telling you that's just a fact. Now, here's what they don't understand. Space is literally saturated with particles. Saturated. Now, all these particles are streaming towards the Earth from the sun. Some of them are spinning very fast, some of them are spinning a little slower. When they impact our ionosphere, which is our atmosphere, which has all these layers of electrons, it's right out here. These are all electron density. It's 2,700 degrees out here. There's no other reason for it other than it's scrubbing all of these particles that are in space, which they say space is a vacuum. Absolutely not. John Glenn went up and he saw all these little fireflies, he called them. And as he was exiting from the dark side here and looking out, he could see them all lit up as they were streaming past in front of him. As soon as he got into them, you don't see them anymore. And when he was coming around this way, as he would look back out, he would see them come streaming past here, banging into the little light particles. He said, thousands of them, thousands of them. We'll go listen to him right now. This is where the atmosphere, the rubber meets the road. Let's put it that way. This is where it gets hot, 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 hot. And directly below, it's minus 100 degrees. All right, so we go 2,700 to minus 100. That's almost a 3,000 degree drop in a very, very close range, because anytime you have heat, you will push cold away. That's the way it works. Heat pushes cold, cold pushes heat, and they separate. All right, this is the issue, and it's very, very serious. Way out here is where the space station and so forth, they're outside the ionosphere. They're above the layer that is the scrub zone. So they're up here sort of floating around above. They're still in a zone that's, it has some density to it, but not like it does here. Right here is where it just crushes. 1,500 degrees Celsius, that's 2,700 degrees, I believe, in Fahrenheit. And this is the impact zone. So this is where you have all your white crushed And that forces black. White and black are basically a unit. And when you have so much white impacting so much other white, the black just stays to its own side. And the black is just nothing but cold. It's dense and it's hot. I mean, it's dense and it's cold. This is virtually nothing to it at all. And it's hot and burns. So minus 80 degrees, which is Celsius, that's 100 degrees below zero. So you go from 2,700 above to minus 100. It's almost 3,000 degrees. And there is a zone right in between them. Now, as the pressure comes more and more, because we're expanding, that means more and more pressure on the outside. It's just the way it's going to work. There's absolutely no way you can get around that. So that's going to condense harder and harder. And that's why the ice is forming way out here. Normally you get a little bitty ice down in here, might form in a really high pressure time, and you get little bits of hail. But now we're getting the hail coming from up in here, and it's coming like this. I saw some the other day, baseball size, easy. It's killing animals and doing all kinds of devastation to everything. And the more it condenses, the more devastating it will be, the bigger the balls of ice will become. And I mean, they could be huge, absolutely enormous. We won't be able to fly planes. Right now it says already they're going to have to fly at a higher altitude. Planes may have to fly higher to avoid the turbulence. Well, what turbulence? Well, the turbulence that's being here as we're scrubbing through the earth, through the space. This turbulence right here. And as we scrub, it's going to get, that's what's creating the tornadoes, the floods, the hurricanes, and you're going to find them where these valleys and hills are, because it'll be pushing it across and something's going to stop it. And then it spirals up and you get all this rain. That's why it's always in the same areas. Well, not always, but it's damn near always. And the Tornado Alley, they used to call it. Well, why? Why? It's because of the topography, it's the geology. And I'm telling you right now, it's getting worse and worse, and I see no way to make it less worse. The only possibility we have to get out of this is to stop the combustion, which means we have to devise a free energy source that is not expansive. And I think I can do that with the light research we did right here, using this to harvest light inside of a shoebox. No expansion whatsoever. We take the white raw energy and use it for anything we want. No expansion will occur. None. Zero. Now, how will we get rid of all these expansion gases? The plants will do that. The plants take the gases and they turn them into roots and bark and everything else, and it just lies there and it just gets compacted. Now, it will reach a balance if we're good custodians of our planet, but we have not been. So we have really destroyed the ecosystem at this point, with no regard for what the true consequences will be, and they will be unfortunate. So I'm just telling you right now, if we don't start investigating, you're never going to get anywhere using fusion and stuff from Fermilab. They don't. I don't want to get nasty, but they're just not interested in helping the world. They're interested in some awards. We did this. We figured this out. We built the biggest device in the world. We made Ice Cube. We dug thousands of feet into the glaciers, and no, it's not necessary. We need free energy, and we need to do it right away. I'm telling you right now, this is just not going to end up well, and every day it's going to get worse. It's not going to get better at all. It's not going to get better whatsoever, and as these fires continue to burn, it will get worse and worse and worse and worse. So I hate to be the bearer of bad news, but bearer I must be. Okay, check this out. This is John Glenn going into space, and he's going to see the particles that are out there, and he's going to see them all brilliantly lit up because they're being hit by the light. And he can only see them when he's in the darkness, looking into the darkness. And then he can see them all lit up on both sides of the earth, looking back and looking forward. But he has to be in the darkness. Now watch this. This is Spacelink
They
TV.
lit up like they're luminescent. I never saw anything like it. They're around the little, they're coming by the capsule, and they look like little stars, a whole shower of them coming by. They swirl around the capsule and go in front of the window, and they're all brilliantly lighted. They probably average maybe 7 or 8 feet apart, but I can see them all down below me also. Negative. They're very slow. They're not going away from me more than maybe 3 or 4 miles per hour. They're going at the same speed I am, approximately. They're only very slightly under my speed. Over.
Now, let me just mention something. He's going to lose contact with the Earth because he is in the midst of all of this magnetic interaction. They can hear him fine for a while when he's not in the midst of these concussive little particles. Once he gets out into the middle of them, he can transfer fine because everything has reached an equilibrium. But he's coming from a non-charged capsule into a charged situation, so it's going to be crackling inside, because he can't transfer his energy out. It's the radiation basically coming into it and going out of it. He loses communications. Now listen.
They do have a different motion though from me, because they swirl around the capsule and then depart back the way that I am looking. Are you receiving? Over.
See, he's in the middle of this electronic interaction, so you see all those little crackles are these things hitting light.
This is Friendship 7. Am I in contact with anyone? Over. This has been going on since about 1+15. Over. Just after I remarked about the sunset, I looked.
See, now listen to this. Just as the sunset, he looked out from darkness into the light.
Back up and looked out the window, and all the little swirl of particles was going by. Over.
It's just at sunset and sunrise.
This is Friendship 7 broadcasting in the blind. Sunrise has come up behind in the periscope. It was brilliant in the scope, a brilliant red as it approached the horizon and came up. And just as I looked back up out the window, I had literally thousands of small luminous particles swirling around the capsule and going away from me at maybe 3 to 5 miles per hour. Now that I am out in the bright sun, they seem to have disappeared.
They are still there and they are still being illuminated, but now he is in amongst the sun with just like we are. If you are in a barn looking through all the dust in the barn and you're in the dark and there's a shining little bit of light coming through, you'll see all the dust particles in that light. It's exactly what he's seeing. He's in the dark looking into the light. Once he was in the light, once you're standing in the middle of the barn, you don't see him. If the whole thing was illuminated, you don't see the dust. You only see it where light illuminates it, and you're from the dark looking into it. That's what he's seeing. Now, what does that mean to us? It means that this is a layer of particles that is being there. That's energy. Anytime you see a glow, that's an energetic reaction. That is going to create heat. It's going to create heat. That's why when meteorites come through that area, they're so big that they hit so many particles at a time, they literally burn up. And that's because the push of the field, it creates that. Just like an atomic bomb. I'm going to show you that once again. I show it over and over and over because you have to understand there's two particles we're dealing with. One of them has all the energy and no mass. That's the bright one. And the other one has all the mass and no energy. That is dark matter and a muon. You remember John Glenn said they're all moving around me, they're moving 3 or 4 miles an hour and they're swishing this way and that way. And and they were like 8 feet apart, something like that. He's saying, I forget what but they were. He gave sort of an idea of how far apart they are. These you could say, well, they're such and such a far apart. These are the electrons that are excited, that are part of gas particles that are in the air. This is right in the air. Rod Warren took these pictures of light accelerating. It's just starting to accelerate. Just light passing through the air does accelerate, does excite the gases to some degree, but they're beginning to get pretty well excited now because it's really pushing hard as it starts to accelerate. It will really accelerate, and I can show that in a second. But my point being is that all of these are particles, just like John Glenn was seeing. He was seeing gas particles lit up, dust, whatever they were, because you could see some big ones, some small ones. If you look carefully, you can tell these things. Now, again, it's pushing forward here. Here, it's light coming in, banging into the light that we, or the electrons that we have here surrounding our Earth. And it's coming down, smashing into them. That's the layer that is hot as can possibly be. And anytime it gets hot, they glow. He said it was glowing like crazy out there. They're glowing. They're brilliantly lit, was just said. They're brilliantly lit. Never saw anything like it. That's brilliantly lit. And that's the particles that he was seeing, not in this intensity. This is the key. We can put it in an intensity and harvest that light. That light is energy. That light is heat. And that's all it is. It has no mass. That's why when you charge up a battery, it just barely changes in weight. There's almost no change at all, because all you did was put in this white stuff. It has no mass, but boy, does it have burn. Okay, let me just make it perfectly clear. When electrons get into our envelope here, they rarely radiate out. The only way they can radiate out is to be extremely intense to break through and get out of our atmosphere. Otherwise, they just get pushed back down. So the point being is that every electron that's created either down here or comes in from above is expanding our atmosphere. It expands, it scrubs harder. It's just as simple as that. And here is where it scrubs, right there. This is the scrub zone. We're spinning through all the gases in space. The sun is spinning through all the gases in space. The sun's ionosphere out here, or its corona, where it scrubs, is millions of degrees. The surface only 10,000. We're 100 or so well, now it's over 110 in places for weeks on end now. Here in the United States, it never was like that before. And it's getting hotter and hotter and hotter. And as it's expanding more and more, it's forcing that heat down in. It's crushing that cold zone, creating huge amounts of ice. So it's crushing here, and this gets hotter and hotter. Instead of being 1,500, it's going to be 1,600, and 1,700, and 1,800. And this, instead of being minus 80, it's going to be minus 100, minus 150. There's going to be a huge, whatever this goes. It's two opposites. And then down here, now we're working with a hard atmosphere. Before it was sort of fluffy, and it wasn't really compact. It's compression, it's condensation. That's what causes ice, rain, all of that. Turbulence, it's compression. And as the Earth spins, and we're spinning, and you're hitting these valleys and hills, it's gonna be terrible. And it's going to get worse. And so what is the solution? The only solution I see is to reduce the amount of particulates, which is gases. Now, they talk about seeding. That's insane. It's exactly opposite. It will have the opposite effect. It will create more heat, just like the particulates that are in the air now are doing. All of those particulates from the huge fires that are going on, and the expansion gases. That's not going to just stop by itself. It's going over and over and over at 164 feet per decade. And it's going to, and this particular fire, I'm sure, is going to be 5-6 decades worth of expansion. You cannot create huge masses of solid things like trees and turn them into gases which are exponentially larger which make our atmosphere blow up like a really hard balloon. It used to be a nice fluffy balloon. It used to be like this, nice and soft and fluffy. Now it's hard, scrubbing through. That's our issue right now, my friends. And if we don't do something about it, I mean immediately, we are screwed. That's the only possibility we got right there. The only possibility I see. Free, portable, non-polluting, not expanding electric energy that could be carried around by anyone in the world to get their water clean, to grow their crops, to do everything that you need to do. Because it takes energy. And the only way right now is to basically burning something. Fusion, they're never going to get to fusion. The way they're doing it, they're never going to get there. They're going to have to put more energy in than they will ever get back out. They've never even broke even. I'm showing you that we can create energy on steroids instantly. The physics of electron showers says if we started with well, here it is right here. This is what the physics say. If you can do what we did, separate the black from the white, you can get minimum of 200 times more energy than you started with. So we started with this amount of glow. Energy is glow. And it turned into that amount of glow, which is, I would say, minimum 200 times more than that, or more. And it's now separated, which is just raw electrons. And it just is fluffy raw electrons. As I will show you, well, let's look at the bomb blast, and I'll show you that they're just raw. When they're in this white stage, they have no mass. The black has the mass. The black is 100% of the mass. You know, when I say that 100% of the mass, it can't be 100% of the mass, the black. The white has to have some mass, but boy, I'll tell you, it is negligible. And what happens is the black pushes the white. And you can see it right here in this one. The black is literally pushing the white. The white is the thing that's concussing, getting glowing. The house will be here, it'll burn, the black lid, and it'll go flying. No mass. Almost all the mass. All right, here it is. This is going to be the separation of the power. I'm going to run it down to slow speed. I'm going to take off the sound because it goes like that. Now, watch what happens. The bomb goes off. Everything will get brilliantly. All of those electrons are just look, it's just smoking. Everything's combusting, but there is no movement, nothing moving. The wires are combusting. Now comes the black, boom, there it goes. Now it will turn back and turn around. Watch. See it turn back around? That's kind of crazy, and the reason is it's trying to get back to the black dark matter, which there's still a lot of it back from the tarmac where it started from. The dark matter is in the center, all the white goes first, and then the black catches up to it, but there's still all the black is more back here. Those things try to come back to recombine. So don't forget, this is all we want to harvest is this white. So whatever we're going to harvest it into, we're going to need a pretty good conductor if it's shooting this stuff. And that is what that bomb blast is. And that's the white. Now, we have a Venturi here. The black is never going to hit the house. All we're letting happen is all the white squirt through the Venturi, and the white will just keep hitting the house forever. But the black can't get to it. In this case, the black can get to it, and it will come along and it will smash through here. But we have the Venturi here, and it can't get through there. So this is never going to happen. All we're going to do is get to this point right here. We're going to be at this point and never get any further than that. And that conductor, instead of smoking and burning it up, we send it down in through a photodiode, which I'm telling you, this would have to be some pretty heavy duty receivers here, because if it's not a thing moved. So we should be able to harvest all that we can focus in onto these substrates, which is going to be a transition metal semiconductor receiver. We could have plates of all kind of transition metals in there, and it will receive all of that that white energy right down into our batteries and just use a little bit to keep it going. I don't see any reason this shouldn't work. And again, there's no mass to this. You carry it around in here. You charge it. You could have little batteries in there, little lithium batteries that would give you plenty of energy just to, you wouldn't even need it because you just turn it on and it just run by itself. You never have to stop it. You could just turn up and down the energy as you needed it. Obviously you would have a regulator. You wouldn't have to do it. But you could use any kind of electricity anywhere in the world. AC, DC, 110, 220, or anything you want. USB. Different cycles, frequencies. I see no other way to get out of this, and this should be free. There should be no patents. There should be everybody in the world should be able to use this as they see fit, and maybe we can get out of this. But there's not to try to harvest a bunch of money out of this instead of trying to fix the world would be a disgrace to society.